Okay, so we have one final video in our discussion of complex numbers and imaginary numbers, and that's kind of an application to something we learned earlier, and that's quadratic equations, quadratic functions, and finding the solutions or roots of quadratic functions, and how we can use complex numbers. Let's think back a little bit when we talked about quadratic functions. There are actually three possibilities for the roots or solutions of a quadratic function depending upon what the parabola looks like. In one circumstance, we can have a parabola that crosses our x-axis, has two x-intercepts, which means it would have two real solutions to it. That's one option for a quadratic function, that the parabola actually crosses the x-axis in two places, has two x-intercepts, and therefore has two real solutions, or as they're also called, two real roots or two real zeros. You might also have a situation where the parabola's vertex is on the x-axis, and therefore there is only one real solution, one real root, one real zero. In these cases, we can call these x-intercepts because they're real numbers. But as we've talked about just in this unit, there is a third possibility, and that possibility is that the parabola never crosses the x-axis. And in that case, there are no real zeros. There are no real solutions, no real intercepts. The example I used right to start this unit, when we started talking about imaginary numbers, was the equation or the function f of x equals x squared plus 4. And I said that you would be reminded, or you should be reminded, that is simply a parabola, the x squared parent graph, moved up 4 places. So it does not cross the x-axis. When we set that equal to 0, subtract 4 and square root both sides, we get x is plus or minus the square root of negative 4. And now that we've done our imaginary numbers, we know that that is plus or minus 2i. So there are actually two imaginary roots, plus 2i and minus 2i. So back up here when we were talking about the situation where it does not cross the x-axis, there are actually two imaginary solutions, or two complex solutions is probably what we should say. Two imaginary or two complex roots. Okay? So even if there are no x-intercepts, there are two complex roots. So what we want to do in this video, and this will be a little longer video because there's a lot involved here, is we're going to talk about these three situations and talk about how we can determine which of these three options we have when we're talking about a quadratic function simply by looking at the quadratic formula. So let's take a look at that. We're going to look at three functions. We're going to look at three quadratic functions. And they are y equals, or f of x equals 2x squared minus 5x minus 12. That's going to be our first one. Our second one is going to be y equals 9x squared plus 12x plus 4. And my third equation is going to be y equals x squared minus 4x plus 13. And we're going to see what happens in each one of these cases. Now, under normal circumstances, we would set y equal to 0, and then we would factor the equation if necessary, if we could, and then use the zero product property. It turns out that you could do that with both of these. But in order to explain what we're about to look at in terms of the quadratic formula and how that will determine how we can choose which of the three possibilities each one of these formulas applies to, we're not going to do it that way. We're going to do it with quadratic formula so that we can see what's going on, although that would be the easiest way to do these. So let's do them one at a time. Let's start with y equals 2x squared minus 5x minus 12. Let me remind you what the quadratic formula is. Quadratic formula says that if we have a quadratic equation in standard form set equal to 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula we're going to use for these three equations. We're going to set each one of these equal to 0 to find out what the zeros are, and we're going to use the quadratic formula to determine what the solutions are. And as I said, two of them you could actually do easier by factoring in zero product property, but we're going to show this with the quadratic formula. So for this formula, a is 2, b is negative 5, c is negative 12. So let's plug in our values. X equals negative b, negative 5 is 5, plus or minus the square root of b squared, which would be 25, negative 5 squared. Let me erase that so that's clearer. Negative 5 squared is 25 minus 4 times a times c. So far so good. Over 2a, which is 4. Okay? Let's do some combining here. That's 5 plus or minus the square root of b squared minus 4 times 2 is 8. 8 times negative 12 is negative 96. So minus 96 is plus 96 all over 4. Finishing up the problem here, we get x equals 5 plus or minus 25 plus 96 is 121 over 4. The square root of 121 is 11. So I have two answers. 5 plus 11 is 16 over 4. X equals 4. And 5 minus 11, which is negative 6 over 4, which is negative 3/2. Now in this case, we have what? We have two real solutions. So we're talking about a parabola here that actually does cross the x-axis 2 times at 4, 0 and negative 3/2, 0. So there's option number 1, two real solutions. Let's look at our next formula. And as we're doing this, I'm also trying to remind you how to use the quadratic formula. So that's part of my purpose for doing this as well. Okay? If I look at y equals 9x squared plus 12x plus 4. A is 9, b is 12, c is 4. Okay, let's put our numbers into our quadratic formula. X equals negative b, so that's negative 12, plus or minus the square root of b squared, 12 squared is 144, minus 4 times a times c. Okay, all over 2a, which is 18. Negative 12 plus or minus 144 minus 9 times 4 is 36 times 4 is 144 over 18. So what we get in this case is negative 12 plus or minus the square root of 0 over 18. Well, the square root of 0 is 0, so this whole portion of the answer here is going to go away, so we end up with negative 12 over 18, divide top and bottom by 6, you get negative 2/3. So this is a parabola, this is a quadratic function that only has one real solution and therefore one x-intercept. Its x-intercept, its vertex, the vertex of the parabola is right on the x-axis. So x equals negative 2/3 is my only real solution. So here we have only one real solution. And in this case, since it is a real solution, it is an x-intercept as well. So this parabola, has an x-intercept at negative 2/3, 0, which is also the vertex for this parabola. Since if we only have one real solution, that means that the vertex is the x-intercept. Our last formula that I wrote up here earlier was y equals x squared minus 4x plus 13. That was our last formula of the three that I wrote up earlier. Let's see what happens with this one. A equals 1, B is negative 4, C equals 13. Let's write it in. X equals negative B would be positive 4, wouldn't it? Yep. Plus or minus, B squared would be 16, negative 4 squared, minus 4 times A times C, all over 2A. Oops, it's not 2A, is it? It's 2 times 1, which is 2. All right, let's keep going here. That's 4 plus or minus the square root of 16 minus 4 times 13 is 52, all over 2. I get 4 plus or minus the square root of negative 36 over 2. All right? When we do the quadratic formula, remember, you always must do two things when you're finished. Number one, simplify the radical as much as possible. And then number two, reduce all the terms if all of the terms have a common factor, all the whole numbers. So let's go ahead and do that. First of all, let's simplify our radical here. Our radical is negative, the square root of negative 36. Well, based on this unit, what we've just been talking about, we know that the square root of negative 36 is 6i, don't we? All over 2. Okay? And then you'll notice we have a common factor of 2 in all my whole numbers. So I can divide everything here by 2. I get 2 plus 3i, and we're not going to write over 1 because it's over 1. So it's just 2 plus or minus 3i. So there's actually two solutions to this, 2 plus 3i and 2 minus 3i. What kind of solutions are they? They're not real. They're complex solutions. They have imaginary numbers in them. So therefore, there are no real solutions. But there are two imaginary solutions. What does that tell us about this parabola? Y equals x squared minus 4x plus 13. It tells us that this parabola never crosses the x-axis. Since there are no real solutions, there are no x-intercepts. So what was the point of all this? Well, the point was to take a look at the quadratic formula. I'm going to pull it back down here to look at all three of our circumstances here and talk about how we can recognize strictly from the quadratic formula which of the three answers we have, which of the three possibilities. Is it two real solutions, one real solution, or no real solutions, meaning two imaginary solutions? Well, let's start with the no real solutions. I think you can tell at what point we knew that there would be no real solutions, and it's right here. When we get a negative under the radical, doesn't that immediately tell us that there's no real solutions? Sure, because if there's a negative under the radical, then we're going to have an I. We don't have any real numbers that are the square root of a negative number. That's been what we've been talking about this entire unit. What gives us two real solutions, if we look up here, is a positive number under the radical. That gives us two real solutions. And what gives us one real solution? If we have a 0 under the radical. Now, the next question is then, what is that under the radical? Well, under the radical, you should know, is b squared, let me write that better. under the radical is b squared minus 4ac, isn't it? This expression is called the discriminant. And it is the portion of the quadratic formula that we can use to determine, even without going through the entire quadratic formula and figuring out what the roots or zeros are, it is the portion of the quadratic formula that we can use to determine what kind of solutions we can expect from our quadratic function. If b squared minus 4ac, if that number under the radical is a positive number, then that means we're going to have two real solutions. If that number under the radical, b squared minus 4ac, is a negative number, that means we're going to have two imaginary solutions, or two complex solutions. Or we can say no real solutions, but let's say two imaginary solutions. And if b squared minus 4ac is equal to 0, we have one real solution. So, what we're saying here is that we don't actually have to figure out what the solutions are. We can use the quadratic formula and determine just from the discriminant, just by doing b squared minus 4ac, what kind of solutions we can expect. So, for example, what if I had, let's do an example here, what about 5x squared plus 6x plus 6? And I were to ask you, first of all, what's the discriminant? And then tell me what number and type of solutions we have. Well, all we'd have to do is do b squared minus 4ac. Well, what's a? A is 5, b is 6, and c is 6, isn't it? Let's figure out what b squared minus 4ac is. b squared, 6 squared is 36, minus 4 times a is 5, times c is 6. 36 minus 20, 4 times 5, 20 times 6 is 120. That gives me a value of negative 84 for my discriminant. That's the value of my discriminant, b squared minus 4ac. And we know from up here, there are three cases, that if my discriminant is negative, right here, that means I have two imaginary solutions. What does that tell us about the parabola when we actually graph it? Well, it tells us that parabola never crosses the x-axis, that there are no real solutions, there are no real zeros, and therefore are no real x-intercepts. There are no x-intercepts. Okay? If we wanted to actually solve this, let's go ahead and solve it. X equals negative b would be negative 6 plus or minus the square root of, we've already done b squared minus 4ac, so let's just write negative 84 in here, over 2a, which is 10, right? Okay, let's do some simplification here. So this is negative 6 plus or minus, let's pull out the negative, which is I, times the square root of 84, over 10. I'm going to leave you to do the math to simplify radical 84. Okay, radical 84 is 2 radical 21. It's 2 radical 21. So this is negative 6 plus or minus 2 radical 21. We're going to put our I in there because it was negative, right? Okay, that's over 10. So first step is always to simplify your radical, and then your second step is to reduce if you can. If all of my whole numbers have a common factor, whole number, whole number, whole number, have a common factor, this can be reduced. And I hope you can see that yes, it can. They're all divisible by 2. So negative 3 plus or minus I radical 21 over 10. I have two complex solutions to that problem. Negative 3 plus I radical 21 over 10 and negative 3 minus I radical 21 over 10. That finishes up our unit on complex numbers. Thanks.